Hello everyone. Welcome to another DevOps Playground, everyone in London office and online. Just a few words before we begin. What's DevOps Playground? We try to share the knowledge. The format will be 15 minutes presentation, give or take. Just to introduce the topic and then 1 hour of hands-on session. We believe in learning by doing, hence the hands-on approach. We'll provide the infrastructure, which Matt, one of our today presenters, will show you how to get. If you have any questions at any point, please shout, whether it's online or in person. We're happy to stop and adjust your pace. So if you get lost or can't get anything, please let us know. Today we'll be talking about testing open source API with Cucumber, and after that short feedback, our speakers will be Olwen Davies and Matt Selman, very experienced and knowledgeable testers. So without further ado, I'll pass the baton or microphone to our presenters, and welcome to November DevOps Playground.
That's good.
They have their own mics, sorry.
We do. Cool. Thank you, Patrick. So, today we're going to be starting with a presentation, just a couple of slides on APIs, Cucumber and Java. After that, we'll go through the demo, and after that, we'll be going through some pizza. So, stay tuned and enjoy. And I'll hand over to Olwen.
So, Cucumber-Java, essentially, this is about behavior-driven tests of an application. So this will allow you to assure access to and use of third-party APIs. It makes development of products faster, and it can widen your achievable test scope. So a quick recap on APIs. They use a set of definitions and protocols to build and integrate application software. So you've probably heard of HTTP, SOAP, REST, different protocols. The format specifies the data that needs to go in the request, and you can expect to come back in the response. Standard methods: get, post, put, delete. And response status codes, which will be your first line of call for verification. Again, they have a system to them, and we've put these in the slides. I won't read those out. The important one is 200. You got a 200, you've got a success. So why do we have to use an API? The great thing about them is that your application can consume reusable assets. You can take the work that other people have written if they make it discoverable via an API. The perfect example being the UK Met Office, as Brits are obsessed by the weather. So you can hook it up to your website and open access to weather climate data. As a consumer, your application just needs the request, response, protocol and format. No knowledge of the application is needed beyond this interface. And an open API will have really good documentation. People want you to use their API. They want their funky functionality put out there and used. The great thing about the API is it maintains independence and segregation. So when that funky source system changes and they've got loads of new ideas, new functionality, you don't have to update your endpoint and your end system unless you want to. So one example is from MuleSoft. This, is within an organisation. We're going to look at simple examples, but within an organisation, they're used at different levels. So, for instance, you have an enterprise, and they're using third-party systems like UPS, SAP, Salesforce, and they're pulling in from their requests response data, which create their system APIs. They probably want to combine some of this for a line of business, e.g. for the sales department, for finance marketing. And so they can do that, and they can structure the data in the way that they want with, you know, multiple sources coming into one. And then perhaps you have your delivery person out on the road with a mobile app. And so the developers can then make that data available to the endpoint end user applications very easily by creating these based on the standard set of data in that protocol there. Okay, so why learn to test via an API? There are a number of things. It assures the API security, performance and reliability, reduces your unknowns. You want to be sure that anything that you're pumping out in your product is actually secure and reliable and performant. And if there are issues, you want to know about them. It's really useful as a test tool. So it can enable a team to test core functionality before the UI is ready. I'll show you an example later. For instance, you know, you have a React app and you want to see how the data will all be laid out and how it will render. As long as you know your API protocol and you can mock up the data, you can pull it in. And the way you're going to know it is by making a call on the source API. So in this way, it can facilitate shift left, the principle where we test as soon as we possibly can. And so we're checking expected results much earlier in the life cycle. Again, segregates the components. Now this is really useful because you want to know, if you're finding a bug, you need to know, is it your Lambda on the back end, or could it be the database, or could it be the user interface? So if you can mock up your database output or your Lambda output and you still see the error, then you know it's the UI. If you can just use the API output, then you still see the bug, then you know it's probably coming from upstream. Now, I want you to think about how many APIs you interact with daily. We were just having a chat about this, and we were thinking, right, okay, get up in the morning, read the newspaper, plan my route to work, do a bit of internet shopping, browse YouTube, etc., go for a run, of course, your Garmin. You just start to think about the number of products there are out there. And this is my reaction. Wow, what do we do? And the answer is automation. So, test automation with an API. Essentially, you're firing requests to the API and checking the responses that you get back. The great thing about automation is without having to get very bored, you can run common parts of the workflow as many times as you like. You can also run them much faster than your hands would allow you, or your brain for that matter. Now the good thing is that once you have Java code that is reliable and that will do your request and your response, then you can change your parameters for effectively any open API, and you can change the format of the data that you're pushing to the API or pulling from it. So for these reasons, it's a critical base and a critical tool for non-functional testing, for performance tests, load tests. It's probably the only way that you can really build up a realistic load without having hundreds of users out there. So a quick example of a way that I'm using API testing at the moment. Some of you may know this is the AWS symbol for the Connect application, which is a telephony contact center application. So out here, we've got our users who are the agents in the call center. So they're going to fire up their icon for their agent desktop, and it'll open up and it'll check if they're logged in. If they're not logged in, off it goes to the login URL, and then straight away it's firing off a request to the Active Directory, which of course protects the whole security of the system. And if it's successful, then it comes back here and it will say, yep, you're in. Now what we need to do is we need to log you into the back end behind this custom UI, which is the AWS Connect system. And again, that has to log in, that has to check. Once successful, a Connect stream will start running, which will actually activate the calls. Other aspect of it is it will call out via Lambda API requests to fundamental bits of functionality which we host on the back end. For instance, a stats Lambda and essentially a telephone directory, fast connects. So what's been great for me is we can fire API requests straight in to the Connect streams with an automated tool, and we can actually simulate the phone calls without having to be the agent sitting on here making it all happen. In the same way, you can have the Connect streams firing in phone calls via requests, and you can answer them here. Another example is the UI has a nice grid which will show how many calls you've handled, how long you've been waiting or idle, and how long you've been busy on a call. So we can check those directly from the Lambda and ensure with a nice bit of code that the tolerance is within 1 second, and that we know there isn't too much delay with those stats being produced, and that they are accurate at all times to anyone who's looking at them. So Matthew's very kindly set up the hands-on, which will show you how to use Cucumber Java. So a very quick run through. The essential aspects of Cucumber is that you have a feature. So that is a clearly defined scope of the application. And from there, you break down into scenarios. So that's the objectives that you're trying to test. What is the application supposed to do for you? And then the steps are, how is it going to work? So that's where you put the actual code in that you need to generate the right requests and responses. The good thing, as I said earlier, you can put in parameters in data tables really easily with Cucumber. And so you can swap around various aspects. A quick example would be this. And here's a link to a 10-minute tutorial if you want to go further with your own learning after. But in this example, we're asking, is it Christmas yet? That's the feature. So one example, it's Christmas this month. And then the structure of a scenario is in given, when, then, which is an established behaviour-driven concept. And then underneath you have your examples, which could be your data table. So here, month, November, today, then the answer would be no. You put December, you could say nearly, and then you could create more specific scenarios where you start to look at the dates and give different answers depending on how close you are to Christmas. So in the actual step definitions, which is the code that runs these tests, it gets generated for you, which makes it very easy if you're not that confident a coder or it's a new format for you. So the given takes the phrase there and then actually generates the code that you are going to have to fill in here, giving you clear instructions with each time. And it includes throwing errors for you. So you've got your given, your when, and your then. So without delay, we're going to start the hands-on. And Matt's going to take you through this. You'll be logging into an environment where everything is pre-installed. You've got a Cucumber Java project. You'll build your own test suite in a Maven Java project. And then you can run tests against the open API that's been selected, requests. and the materials are available for you online with the DevOps Playground GitHub repository. So, enjoy.
Okay, so my screen's being shared. So first things first, I'll just show you what we want to have open and what windows we're going to be going through. So we have the GitHub repository open here, and we have the README and everything. This will be where we're getting the code from. All the code you need is here. Secondly, I've got VS Code open. I'll show you how to open this in a second. Thirdly, I've got the terminal open, and I'll just type in the password now and give that a moment. There we go. And then request, which is the API we'll be making the request to. As you can see, there are a number of requests down here, so if in your own learning you'd like to look into some of these, feel free to do so. So the first thing you'll want to do is go on lab.devopsplayground.org, and that is DevOps Playground being one word, and you should be able to, I don't know if I can make it bigger, but it's lab.devopsplayground.org. So I'll just give everyone a second to get onto this page. Cool. So once you're on that page, you can type in your username into here, submit, and it should give you the links on where you need to go. So that'll be your Meetup username. So it's the username you used on Meetup to sign up to the event. So we're just giving everyone a moment to log in. Yeah, that's fine. Okay, so we've got the coder open, you've got the Wetty open and logged in, and we'll have GitHub open as well. So the first thing we can do is look at some of the code. So we'll be, for the beginning part anyway, using the POM XML, and we'll also be using the testrunner.java. You'll see the imports in here have already been done, and that's just for ease of use at the moment. So to begin, we'll want to go to the POM XML, copy the code here, and then on line 11, between the two dependencies tags, that's this dependency tag here and the closing dependency tag here, we can just paste in those three dependencies. Let me save that. So what this does, so the first one allows Cucumber to talk with Java, and that's just a library that allows us to do that. The second one is allowing Cucumber to talk with JUnit, again very similar. And then the third one is JSON, and that just allows us to manipulate JSON, which we'll be doing towards the end of this talk. So if we go back to the README now, and again, that's just between the dependencies tags here and the closing tag here, and I pasted everything onto line 11. So if I go back to GitHub, next thing we want to do is set up the test runner. So we can copy this. We can go down to our testrunner.java, and we can just paste here. There's a duplicate of the imports. We can get rid of those. And we save that. And then I just refresh this, just make sure. So this you can just paste onto line 5 and just paste it in. You don't need to do any edits to it. So we've got those two things. They're both saved, they're both set up. So if we go onto the WESI, then we can type in mvn and test. And if you run that, then we have a build failure. Oh, that's why, sorry, I need to cd in. So ls, so you want to be in the same directory as the POM XML. So if I go into work directory, and then cd testing open source API with Cucumber, and then you can see we're in the same directory as the pom.xml. So again, if I type in nvm test here, then we should have a successful build and some downloading. So we just give that a moment to download. And build success. So that's the setup of the project successfully done. Oh, good. Sorry, I had an older version of the README there. So just to talk about the project object model, or POM file, for a second. So this is a fundamental unit of work in Maven. It's an XML file that contains the information about the project, and it's also got the configuration details, and it's where you can store your libraries. You can also find your libraries, well, organically, I suppose, through the Maven repository, which is Maven repository, or mvmrepository.com, and that just looks like this. And there are a number of libraries in here that you can use at any time. But for now, we'll just be using these 3 libraries. So we've got the POM set up, and we've got the test runner set up. So now we can close these 2, because we won't be needing them again. What we'll be needing at the moment is the feature file, the HTTP request steps. So if I just pin this here, HTTP request steps here, and then the base URL here. We will be using common methods, but that's for our JSON, and that'll be further down the line. So if we go back to the GitHub and we start adding in the HTTP requests, we'll be doing 4 today. We've got a get, a post, a put, and a delete. The get reads information, the post creates information, the put updates the information, and the delete deletes information. This is referred to as CRUD, or create, read, update, and delete. There are other verbs too, other than these 4, but these are the main 4 ones that are used in all APIs. We've also pre-built some abstraction for this. So our base URL this is where we're going to store some common variables that we're going to use. And then later on in our common methods.java, that's where we're going to store some common methods that we can use. So let's get started with that. So first thing we're going to do is fill in the GET request. So if I go and copy those 4 lines, and we go to HTTP request features, and we paste this in. Now, what this does is give us the framework to work from. So we created these steps. So given I create a GET request is a step. When I run a GET request is a step. And then the status returns 200, that's also a step. So if we go back to the WETI and we run nvm test once more, give that a moment to load, and you should see it's failed, but what it has done is created the step definitions for us. This is quite useful, since any variation in the wording of step definition from the step in the feature can cause errors. So having them pre-made for you avoids, most of the time, avoids errors. But we won't be using those for now. What we will be doing is taking the step definitions from the GitHub repo. So the first thing we're going to do is define the given step. So if we copy this line here, go to our HTTP request steps.java, and then on about line 19, we can just paste in our first step definition. The first thing we have here is the glue. So given I create a request, this is just a string. So if you look on the feature file, you'll see this string here. That corresponds directly to this guy here. After that, we have the method, and you'll see we have string request type. That is being passed through the glue here and through the feature here. So the word get is being passed through into here as request type. Then we have if the request type equals ignore case get, so if it equals get in any format, uppercase, lowercase, then it follows through with this if statement. Then we have a variable called get that we're not creating yet, but we will be soon, equals HTTP request new builder, URI create base URL name, this we'll also create in a moment, and this is just creating the builder and it's pointing it towards our API. After that we have the definition of the request, which is a get. We're setting the header, so that's what the people at request are going to be seeing, and then we're just building that. So if we go back, we can take the HTTP request get and the base URL name from the README here, and we can define them in our base URL, and that'll be on line 11. So that's the first step done. So this step has now been defined. Now we're on to the other two. So if we go back to GitHub, and then once again, we take the when, and we copy it in our step definition file, and just as a new method here. So you can see it follows roughly the same lines when I run a string request. We have the glue, we have the method name, throwing in request type, we have the if statement, we have the response, an undefined variable, but we'll define that soon, equals HTTP client, send get. So this is the get we created up here, and then just checking the body here, making sure it's of a string. We have the actual code, which again hasn't been defined, but I'll define that soon, and that's just taking the response and then getting the status code from our response. And then we're just printing that out. So if we go back to the GitHub, and we're on the when here, so if we copy these two variables here, where we're defining the response as a string, or an HTTP response string, and we're defining the HTTP client. So we'll take those two, we'll go back to our base URL, and we'll just slot them in there. So that's our second step done, and now on to the third and final step. So if we just take this method and we go back to our step definition file and just add it at the bottom here. Once more, we have the glue. Then we have the method name. We're taking the integer of status code and we're asserting that the status code equals the actual code. The actual code we took from the when step here. And then we need to define actual code. So we'll put that once more in our base URL. And that's all done. So we have our feature here with the 3 steps. We have the 3 steps defined here in our step definition. And we have the variables defined here in our base URL. So that's all saved. And then if we run it again using mvm test, we should have a successful build. And you can see we have, and you can see we printed out the response here. This is quite bare bones for now, but we will fill this up later. Again, this supports reporting, but we won't have time to go through reporting today, but we will be going through reporting. Well, we can go through reporting at another time. So that's our GET request. Now on to the POST request. So we're using a data table here, as you can see. So once again, Cucumber is a behavioral-driven development framework that allows developers to create text-based test scenarios using Gherkin language. In many cases, these scenarios require mock data to exercise a feature, and this can be quite cumbersome to inject into the code, and this is particularly complex when you have multiple entries. So what we can do is mock this data using data tables, and we can put this into the feature file, pull it through the step definition, inject it into the code, and it's quite good for that. So if we just copy this, and we go back to our feature file, and we just slot it in here. Notice we're using a scenario outline rather than scenario, and this is the difference between the simple requests and the data tables, is that the data tables will always require a scenario outline. This is the data we're injecting here, and this examples is where we fill up that data. The when I run a POST request is approximately the same as we had with the GET request before, and the status returns is also approximately the same. The advantage of this is you can have a lot of data. So if I just fill this up here, you can have 15, 20 entries in here, and it doesn't look too messy. You can also have 15, 20 entries down here. Obviously, in real life, they'd be in order that's aesthetically pleasing. And generally, you want to put these at the bottom of your data, of your feature file, because otherwise it can get a bit messy at the example stage. But for the most part, it's quite clear because you can see the data table, exactly what you're trying to put in without having a lot of fluff to deal with. So I'll go ahead and define these now. So if we go back to the README, we can copy for the given step. And what we'll just do is go here and we just slot it at the end over here. Once again, we have the glue at the top here. We have the method, and you can see we're passing in the request type, which is coming from the string, and we're passing in the data table, which is coming from our data table. We have if request type equal ignore post, and then we have items to load. That's an undefined variable, but I'll define that in a moment. And that's taking the data table as maps with strings. Here we've got the for loop, and we've got items to load.size, so it's looping through the size of the table, and we're defining a variable called post, which is very similar to what we had in our earlier GET request. Then we're defining post here, so you can see in the GET request we defined GET, now we're defining post. And we've also attaching a body this time, so that's attaching some strings. And you can see we've got variable items to load in here as well, so that will be looped through as we go through. Then you're setting the header, same as before, and you're building, the same as before. So, if we go back to the GitHub, we also need to add something else, which will send the POST request. And we can add this on line 35 at the end of this if statement. So at the moment we got request type equals ignore get. Once we add this, it'll be if else or else if. request type equals post. And you can see it's sending a response, but this time we're sending post instead of get. And again, we're getting the status code in return. So if we go back, and we're defining two variables here. We're defining the HTTP request post, and we're defining the items to load as a map. So we take those two, and we put them at the end of our base URL file. Good. Now, this should be ready to run. So I'm just going through, making sure I've saved everything. And once again, we can run with mvm test. Give that a moment to load. And you can see we've got two here now. So we've got the get with a response of 200 and the post with a response of 201. 201 in a post request just means it's successful. So, onto the put request. Again, this is update rather than creating data, but it is very similar. Sorry? Zoom in. Yeah, sure. Is that okay? Will do. So if I just zoom in on the terminal as well, just so everyone can see it a bit more clearly. And I'll zoom in, yeah, on the code. Cool. So, for the put request, very similar to creating data. This time we're just updating data. So if we go back to our feature file, and we can just slot this in underneath our post request. You can see we're also using a data table, and it's very similar. This time we're getting a response of 200 rather than 201, but essentially the rest is very similar. So go back to GitHub, and we take the step definition, and that's just defining this given step here, since we're using a put rather than a post this time. So we can put this at the end of this if statement, which is for me on line 49, and this would just be an if else for putting rather than posting. So you can see the glue is the same, it's just this string that's different. So we got the put here, we've got items to load once again, we've got the for loop again, we've got put as the variable, and we've got put as the type, and again we're sending off a body of the same type, setting the header and building. So if we go back to GitHub, and we can put this next line of code once again. So if we scroll up to our when step, when I run a request, we can put this in another else if, which in this case is sending the put request, whereas before we're sending the post and the get. So that's that defined. And we have this variable, HTTP request put, and we can just put that in our base URL. Once again, a repeating variable, so a bit of abstraction here. And that's everything for the put request. So we go back to the wetty, and we type in mvm test, and it runs. And we have a 200 response from the request, and you can see we're using a slightly different URL this time for each of them, as per request, and I believe, yeah, this is the one we're using. So, if we go back, we've got one more request to do, and then we can move on to some JSON. So finally, we have the delete request. This is very similar to the get request. So we go back to our feature, and we just post this guy in. So given I create delete request, when I run a delete request, the status returns 204. 204 means success, and again the wording's changed, but the lines of code are similar. So if we go back to our GitHub, and we can take the definition for this, and we can put it in our step definitions file, and we can put it underneath the get request. In the same way, when we created the tables, we had post and put together. In here, we can put delete underneath the get, because as you can see, they're very similar. So we've got the delete variable being created. The glue is the same. We've got HTTP request new builder, and we're just hitting the URL here. Then we've got the delete being set as delete. We're setting the header, and then we're building, same as before. And then if we go back to our GitHub, all we have to do now is add the variable, and we'll be doing that once more in our base url.java. So we can just paste that in. And then we can go back to our Wetty and we can run it. Once again, using nvm test. And we have a build failure. 204 but was 200. I must have missed something in the README. Bear with me. Did I miss? Yeah, I think I did. Okay, so I think I missed a step, which was this guy. So you want to copy this guy, and then go back to our request steps. And then, yeah, I did. So we've got get, we've got post, and we've got put underneath this when I run a request. We want to put delete in here as well. And once again, this is just sending the response. As you can see, this takes the get variable we created in the given step. This takes the post and the put we created in the data table step. This one will take the delete that we built up here. So we have that, save that, and if we run again, that should work this time. And we have a success. So, delete gives us 204, that means the delete succeeded. Put gives us 200, which means the update has succeeded. Post gives us a 201, which means the create has succeeded. And then the get gives us a 200, which means the reading of the data has succeeded. So, let's have a look at what we created here before we move on to the JSON. So if you look, we have the get request, the 3 lines here that are created. We have the post request where we're creating data, and this is done with a Cucumber data table. We have the put, once again with the Cucumber data table where we're updating the data, and we have the delete where we're deleting data, and that is in very similar format to the get request, which was reading the data. So then we have the step definitions file. So we have got the given step for the get and the delete. Now, since they're very similar in scope, there's an if-else statement separating them. Then we're running and sending off each request type. So the get, the post, the put, and the delete. After that, we're returning the status code, and this is the same for everyone. And then the data table here, we're creating the post on the top and the put on the bottom. Then we've got the repeating variables just here in the base url.java. So what we're going to do next, we're going to do some JSON manipulation. We're going to start at the top level, and then we're going to move on to the nested level. So if we go back to GitHub, so JSON is an open source standard file format and data interchange format that uses human readable text to store and transmit data objects consisting of attribute and value pairs and arrays. They're also called key value pairs and arrays, and if you have the key, generally you can get the value using that key, and we'll see that here. So first, for the top level, what we want to do is we want to copy this and the per page from the responses 6 from the README, and we want to add that onto the end of our get request here. This also brings us to not quite the full repository of words for Gherkin, but we have the given, we have the when, we have the then, and we have the and that's what's generally used in feature files for the Gherkin syntax. So you have given a condition, when I do something, then the result should be so, and then and is for any extra things on the end of that. So go back to GitHub, what we're going to do now is take that step, and we're going to basically furnish the step with a step definition. So this will be something new, so on line 89 for me. We have then, and then the glue here, which directly corresponds to the feature file step here. Then we have the method. We're putting in the key here, and we're putting an expected value here. Then we're getting the response body and turning it into a variable. We're turning that variable into a JSON object so we can manipulate it. And then we're printing out that JSON object as a full response. After that, we're asserting that getting the value for the JSON object in the key, turning that into a string, and then comparing that to the expected value. I'll show you this getValue4 method in a second. And then we've also got an integer top level equals JSON object get integer key, because as you can see, if we go back to the feature file, we're getting an integer here. And we're just printing that out. So, if we go back to GitHub, we can declare this body JSON in the base URL file. And we can just slot it at the end here. And then if we go back to GitHub, we can get this getValue4 method, and we can open common methods, and on line 8 we can just paste that in. So this is just an object getting the value for the JSON object and the string key, and returning the JSON object.getKey. So we're getting that key value out of the JSON object. So if I go back to GitHub, and I think that's everything. So if we go to here, just make sure we saved it. Then we go on to Wetty, and we once again run nvm test. So give that a moment to load. And you can see we've got some JSON. So our get request is still here, as are the post, put, and deletes. We've got the line we're printing out where the top level object is per page, which is 6, and then we've got the full response. So you can see the top level object here, per page 6, is what we're getting. We've also got total of 12, which we're also getting. And then you have a nice long array here called data. And then one element out of this array is that. So we've got last name, ID, avatar, etc. We'll be working on that in a moment, but for the moment we're just interested in these 2 top level items. So go back to GitHub. Now we're going to do the same thing, but in a different way. So, and I print the response using key ID. So we want to put this on the end of our post request here on line 15. Then, going back to GitHub, we want to take the glue and the method for that. We're going to put that in our step definitions file. And again, it's going to be a new method. So we just put it in here. So the glue is there. We're passing in the key value that we want. Again, we're printing the, we're turning the response.body into body.json, or body.json, sorry. And then we are turning that into a new JSON object and then printing that JSON object. And the key using print JSON response, which is a method down here. So we can just copy this. And then we can go once more to our common methods, and we just paste it in. So, print JSON response. We're passing in the object and the key, then we're printing the full response first. Then we've got string top level, string value of the JSON object get int, so we're getting an integer once again, and we need to turn that into a string, and we're turning it into a variable string top level, and then we're just printing that out. So, make sure that's saved. Go back to the README, and that's everything for that. So if we go back to the Wetty terminal, and we run nvm test. And give that a moment to run. And you can see we've got a bit more. So again, we've got our original get request here. We have our original post request here, and we have the put and delete here. We've got the top level object, which is per page. We've got the full request response here, and now we've also got the full response here from our post request. And you can see there are two items in this, ID and created that. And then we're saying top level object, which is ID, 448, and that's what we printed out earlier. So that's how you can grab hold of a item on the top level. And then we come to the array. So if I just copy this, and we're once again going to put it in our feature file. We're going to put it under the get request, since we have a nice big array from that. Save that. Then we're going to define our step. So if we go back to HTTP requests, make a new line, and then we can just furnish this. So you can see we've got the glue here. We got the public void. I print the response array, so the method name. Body JSON equals responsible.body, and then we're turning it into a JSON object once again, and we're passing that into the print response array. So, last bit of code. So we're going to copy this, and then we're going to put it in our common methods, and I'm going to talk you through it. So, we have printing the response array, we're passing in the JSON object, we're turning that JSON object and getting the array out of it using data. So if I go back to the terminal here, you can see we've got the full response, and then we've got this array called data. So let me get rid of that. So data is what we're trying to grab hold of here. We're getting the first element out of that array equals JSON array get JSON object 0. We're printing out the first element from that list, and then we're printing out space so it's not too messy. And then we're going looping through it. So we're going through the length of the JSON array. We've got the JSON object that's been created from the JSON array get object get counter, and then we're taking particular values. So we're creating last name from posting, and we're getting basically get string command from JSON array nested contents, which is the JSON object, which was the JSON array from earlier. And we're getting the key value from there. So last name, avatar, and email, and these will give us the values associated with those keys. Then we're printing a blank line just to keep it keep it clean. Then we're printing out the array list index plus the counter, so we know where we're at. We're printing out that particular response, so that section of the array. Then we've got the last name from posting, the avatar from posting, and the email from posting. They're being printed out individually. Then we've got another blank line, and this, once more, these two here are just grabbing the particular elements of that array. So not particular values, not particular keys, but they are grabbing particular elements of that array. I'll show you in a second. So we save that. Make sure there's no other code, and we can go to the WESI and once more run nvm test. So, going back through it, we've still got our original response, we've still got the full response, which is this. We're still printing out that top level object, and we're also now printing out the first element from the list. So if we go back here, that's this guy. Then we're printing out the first element from the array. So we're printing out the whole element. Then we've got the last name, avatar, and email. And that corresponds directly to this list we have here. And we're looping through and going through each element. So each time we're printing that particular element from the array. Last name, avatar, and email. And we're doing that 5 times. And then these two at the bottom here are at the end of our for loop, and correspond directly to these two here. So, like I said before, we're printing out a particular element from this array. And that's everything. So we come to the end of the file here. Now, so what have we done? So we have got a GET request where we're getting a top level response, and we're also getting the nested response from the array. We're returning the status code. We're creating that request and we're sending that request. In the post, we're using a data table to create a request and pass in data. We're running that and we're getting a status return. We're also getting a top level element from that return. In the put request, we're once again creating data, well, updating data, but we're creating it in the data table here. We're running it, and then we're returning a status. And then the delete request is creating a delete request, sending a delete request, and getting a response back. If we go back through the steps, again, we've got if statements that tell us whether we're using a get, a delete, a post, or a put. We're sending these requests we've created, and we're getting the status back. And then we're creating again with tables, and we're also getting the responses in these three methods here. Base URL, this is where we've stored our variables, so they can be reused over and over. And then we've got our common methods, where we're taking the JSON object and we're taking keys from the JSON object. And we're also printing out the JSON object array. So we're getting the array from the JSON object and printing out that array. And that's everything. So, thank you for listening. And any questions? So, sorry, Patrick, do you have the microphone? Sorry, I'm a little hard of hearing.
Patrick, mic's not on.
Mic's not on. Do I need to turn it on?
Yes, please.
Technical. Do I know how?
Yeah. Could you use
Both sides. Patrick, have you turned the receiver on as well?
do you want to use mine?
I think that should be on.
Is it on?
Yes.
Yeah, it's on.
So like for Java, we use JUnit testing, and we can send data to SonarQube to see the reports, vulnerability, those kind of stuff. Can you also do that with Cucumber as well?
Yes, you should be able to use Cucumber with JUnit. Generally speaking, Cucumber is a bit too bulky for JUnit, so it's used for automation testing rather than unit testing. But yeah, no, it is possible.
I mean, like, whatever test we executed, can we have a report for done this? Like, instead of just saying in the Maven, it's better we have a report so that we can submit to our other people, so that they know that okay, we did this test and we can move to the next level.
Yeah. So yes, you can. It will generate Cucumber reports.
Reports, okay.
Yeah, but that's out of scope for what we've created here. It is possible though.
Oh, it's possible. Okay.
Yeah.
Thank you.
Sorry.
Okay, does that work? I got some questions from online. Sorry for my very carrying voice. Does Cucumber/OpenAPI gives you the way to test more complex calls? In example, something with authentication. If it does, how reliable mocking the authentication is, and what authentication methods are supported. So, 3 in price of 1.
So for authentication, you can use authentication with Cucumber. You can pass in data. So authentication data can be passed in like any other value. On Request itself, it does have a login, but I haven't used it before, so I don't know how realistic it is. So you've got a login for successful and you've got a login for being unsuccessful. But again, I don't know how successful this would be, and my personal experience with authentication has been through, well, applications like Salesforce. So I've had basically a standardized logging in process. So I can't, don't really know based on that question, but you can use Cucumber to pass in data, and you should be able to use Cucumber to pass in login details.
Okay. I think the question was like towards potentially client certificate and tokens, like how this handle mocking those. That would be my gut feeling.
Yeah. Again, you can send in data through data tables. So if I just go back, so you can send in data like this through Cucumber. That's the only way really you can send in data. So
Cool.
you can mock it through the data tables.
And I've got one more. What are the other tools on the market you would use for the similar use case? And why would you use Cucumber rather than something else?
So Cucumber I've been introduced into a while ago, and I've never really needed anything else. So I've never had to look outside of Cucumber to see any other similar tools. I don't know if there are any superior to them. I don't think there are. But yeah, send them over if you find one that is superior, because I would like to see it. But yeah.
Cool, sounds good. And the very last one, what would you recommend to learn next? What would be the next step? What resources would you recommend to dig into?
Well, RecQuez is always good. Looking online, just seeing what's out there. Looking how to authenticate. So you can also hit the Jira API. Jira has a free API that you can hit and use for authentication and things. GitHub as well has its own open API that you can hit. So trying to expand on this, correcting any mistakes I've made in this framework, adding authentication, adding Cucumber reports would be a good place to go from here. Good next step.
Cool, that's all I had from online, unless I haven't seen anything. You also had a brilliant playground from one of the viewers.
Thank you.
And then, nothing else? Cool.
Cool.
Well done then.
Thank you, everyone.